Here's the power converter for a friend of mine's trailer, which is a travel light hybrid camper. And I'm not sure the make of this power supply. There's some part numbers here. I believe it might be an Atwood, but I'm not sure. This is the DC side. This is the AC side. And the problem with this is it's only outputting half of the DC volts that it should be at this point. So obviously it's not charging his battery, and it's his lights are very dim. So you try to figure out what's wrong with this thing, and I don't have a schematic for it, so I'm just going to be doing some really simple visual tests here to see if I can find the problem. And these are things that you can do at home. They're very quick and easy, and you know, could save you a few $100s. But we'll see if this thing can be easily fixed. Attention is drawn very quickly to these two resistors right here. Just because there's some discoloration on the circuit board. It looks like they got a little too hot. So there's something definitely going on there. Looking at the caps, that's just kind of like sawdust right there. That's sticking to the glue. I don't see anything else that's jumping out at me right away. That's the main thing. So what we'll do is we'll get this, I've already unscrewed this, but basically just going to, I've taken the fan off, and I'm going to take the AC out of here, and then this board will just pop right out of here. So, alright, I've already plugged this in once, and make some pretty strange sounds. Voltage is all over the place. There we go. So now it's reading the correct voltage. But I had just plugged it in previously, and it was it made a really weird noise. I see these two resistors here are burnt, so let's flip this over. Alright, here's something that I kind of noticed immediately right away, but just wanted to plug it in just to see what it was doing. Obviously these resistors have gotten really hot, and they've lifted the pads. And this one's actually just broken right off the circuit board. They've lifted these pads right off. So I can reflow those, resolder those, and hopefully that'll fix the problem. I don't see any other solder joints here that have overheated and cracked. Now, of course, I don't have the schematic, so I can't tell what these resistors are doing. And I would be at a loss to know why that happened, but I can fix that and see if it makes this thing a little bit more predictable and stable. Alright, I've soldered those two solder joints down, and this thing is was working okay. And that is the sound that I'm talking about. I have no idea what that is, but I think that's a high frequency switching transformer. Really, really odd sound. It is working though. Doesn't sound too healthy though. Something ain't too happy in here. Not sure what it is. Maybe one of these power transistors is on its way out. Something up there. It's working though. I wonder if we put a load on that, on the output, what'll happen, but yeah, there's something wrong there. This is a strange noise. It's like it's not even really like a tone, it's a... Anyways, I'm gonna turn this off. If I plug this in, and you can hear it. Plug it. Jumping all over the place now. Oh! Just came back on. Now we're getting 13 point... Oh, it's got to be those resistors. Oh, I see. I think it's this guy. Oh boy. Yeah, one of these power transistors. That's what's making that noise. Which one? It's not any of these ones. It's one of these two here. This is high frequency switching stuff here. That's okay. Okay, so I think I narrowed it down to one of these two power transistors. Something wrong there. I'm just going to stop the camera here and try and dig in there, see what's up. Alright, now this is the back side where these power transistors are. I've noticed something really interesting. Look carefully at the solder joints. This particular power transformer is being noisy. You could see a crack in the solder joint, which goes all around. It's all around that. I'm not sure if it's the drain or the source or what. This is probably Anyways, looks like both those solder joints have been, especially over here, if you look at it close, it looks like it completely blew out. So I wonder if I just reflow that, if that's going to solve the issue. Also, I noticed that the grounding of these heat sinks is, these are all loose as well. So check these other solder joints. Maybe perhaps, okay, well that makes sense that why we're getting half the voltage, because you know, obviously each one of these takes care of one side of the wave. So let's reflow those joints and see if that helps. I'm going to stop the video. Okay, here's the underside of where these two power transistors are. Here's their heatsink. And notice something really interesting here. With this noisy one, you can see that this middle solder joint is completely blown out. Very hard, very easy to miss. But yeah, it's completely blown out, as well as the one on the right side as well. Sort of looks like it's cracked. Make sure you know what I'm looking at here, but it's this joint here, which is actually loose. Actually loose in there. Something has blown the solder joint right out. So not sure why that would be, but I've also noticed, yeah, so let's reflow those and see if that fixes this problem. Again, I don't have a schematic, so I can't figure out why that would happen. But if I reflow that, and that is the consistent with the power transistor that is making the noise. And checking the rest of them, they look good on the AC side. That's a high frequency switching power transistor, I believe. Actually, I could be wrong about that. I'm not sure. I think these transformers are this one here. I think it's a high frequency. I'm not sure. But this might be a switch mode power supply. Not super into these newer power supplies. I like the old stuff, the old beefy stuff that's not fragile and that doesn't have any logic in it and stuff like that. But anyways, let's reflow those joints and let's see if this fixes the problem. Alright, just waiting for my iron to heat up here. I should do a video on this beast of a soldering iron at some point, but I can't hold the camera and solder at the same time, so I'm going to have to do this off camera. But and I'm going I was just going to say, I was thinking about how hot I should do this, just because there's a transistor. Be set 900. That's pretty hot. We'll go 800. It's still pretty hot, but better to be pretty hot and not have to stay on it for long, I think. Anyways, let's do this. Alright, I bet you any money this thing's gonna fire right up right now. Oh, let's get our voltmeter on. Okay. Fingers crossed. So far so good. There we go. 13.74 volts. And dead quiet. Let's do the old poke test. There we go. Okay, I think this thing's fixed. That's pretty cool. Now again, I want to stress that I do not have the schematic for this. Oh, I hear that sound again. Where would that come from? Oh, wait a second. Wait a second. Wait a second. There's another thing I'm noticing here. I'm looking at that fair. I don't like the way that fair. This obviously got hot. And I don't like the way those ferrite beads are kind of touching, kind of. I'm not sure if they're conductive or not, but they're definitely touching the terminals of the transistor. So that ain't good either. Maybe this problem is just going to happen again if we don't fix that. So let's see what we could do about that. Alright, now I've just pushed that little bead over so that it's not touching it. It's an iron. Let's see if the camera can focus here. It's an iron, some kind of an iron compound, these ferrite beads. So I don't know if they're conductive or not, but it would make sense if they were. So that could have been shorting that terminal. Let's plug it back in. I just moved it over slightly. Just that goo stuff there. I mean, it's obviously got hot. It looks like it might have boiled at one point. But let's turn this on. See what happens here. All right. 5th time is the charm. Let's see what happens. Climbing. Nope. You can see it jumping around. I think that part is malfunctioned. What is this? This is a T408 MBR 4060 PT T408 MBR. I think that transistor might be malfunctioning. Let's check it out on the computer. Alright, here's the managed to locate the data sheet for the MBR 4060 PT, which is a 40 amp Schottky rectifier, which makes sense now. I know for sure that this is a switch mode power supply, a high frequency. Say here it's a high frequency inverters. So usually the Schottky diodes get used in the high frequency applications, so makes sense, and also makes sense with the noise that it's kind of making. So there's a bunch of other information here: forward bias, voltage, and power dissipation, 3 watts. I'm pretty certain at this point that that Schottky rectifier there on that side is blown, since that's where the noise is coming from, and you know, tapping it makes it do that thing. Also, I think that's probably why the solder joint underneath got blown out as well. So I'm gonna go ahead and order this part. There's a 15-week waiting period on this, so it's not going to be here anytime soon, but I'm fairly certain that once I get this part and put it in, that power supply is going to work just fine. Now, this is not an expensive part, it's just going to take a while, so I think I'll make this a two-part video series, this being part one, and then when I finally get this part and put it in, then we will hopefully have a part two, which will be a successful repair. Hopefully, fingers crossed. Thanks for watching this video. I hope that this helped you out some. If you have this same power converter in your trailer or RV, just know that it would seem as though it's not a very robust converter, and you could have some problems with these diodes here, these high frequency switching Schottky diodes. Anyway, stay tuned to my channel, and I will hopefully have a part two video for you very soon. And thanks for watching. You Ottawa Scotty signing off.